Hi there, my name is Brandon Tatram and I work on the developer experience team at Blues Wireless. We recently launched a simple, developer-friendly cellular IoT device and I'd like to share it with you today, as well as how it can be used for your LoRa-based applications. Now at Blues Wireless, we've created something that we think makes using cellular for a number of IoT use cases finally simple and affordable, including as an option for LoRa applications. And it's a module called the Notecard. The Notecard is a device-to-cloud data pump that's ready to embed into new and existing applications. It includes a cellular and GPS GNSS module from Quictel, an embedded SIM, an onboard Cortex M4 MCU, a secure element with pre-provisioned keys, an onboard accelerometer and temp sensor, and an M.2 edge connector. Now, as a developer myself who has worked with a number of IoT solutions, what I find most compelling about the Notecard is its cost, the fact that it's a low-power cellular device, and its API. With the Notecard, you get 10 years of data and 500 megs included with the cost of the device, and devices start at $49. You'll never get a monthly bill for SIM usage. One way to look at it is that the Notecard is like the Kindle of cellular IoT. We have narrowband and wideband versions of the Notecard with coverage in over 135 countries. Depending on the Notecard you choose, we support narrowband IoT, LTE-M, Cat-M, and Cat-1 networks. And compared to other solutions, the Notecard ends up being up to 10 times less expensive for 10 years worth of cellular service. The Notecard is also a low power by default device. It was designed to operate in battery and solar environments and draws as little as 8 microamps when idle. That's less than the internal self-drain of most batteries. For example, a standard 2000 milliamp LiPo has a self-drain of more than 75 microamps continuously. It's also a secure device. Keys and certificates are burned to the onboard ST-Safe module at the factory, and all communications between the Notecard and our cloud service occur off the internet via our own managed VPN. And the module is also PTCRB in-product certified, meaning that you can include it in your own products without having to recertify the radio. Finally, and this is one of my favorite features, the Notecard speaks 100% JSON. It takes JSON requests and returns JSON responses. No AT commands are required to turn on the radio, perform a sync, connect to GPS, or anything. Everything that you can do with the Notecard is wrapped up in a JSON-based API that is simple and flexible. It's also documented extensively at our developer portal, along with complete guides, tutorials, and samples. Now let's take a look at the Notecard API now using our in-browser playground at dev.blues.io. I send simple JSON commands to check the state of the Notecard's wireless connection, to add data to the device with a note.add request, and to initiate a sync with the NoteHub cloud service. You'll notice that the responses to my JSON requests are themselves valid JSON objects. And every Notecard comes pre-provisioned to talk to the Blues Wireless Cloud service, notehub.io. NoteHub is a secure device console that gives you the tools to manage a single device, a number of devices and fleets, anything. And the devices are auto-provisioned using a secure VPN tunnel, and they connect as soon as you power them on. The NoteHub enables bi-directional communication with the Notecard, as well as the propagation of device, fleet, and project settings through environment variables. And through the device console, you can monitor device events, sessions, as well as the onboard temp and voltage settings on a Notecard. Finally, the NoteHub provides a facility for performing OTA firmware updates to the Notecard firmware, as well as the connected host microcontroller through the Notecard API. NoteHub allows you to route your project data to any cloud application. Really, it's designed to be a middleware between your devices and your ultimate cloud apps. We provide built-in routes for major cloud providers, as well as support for routing to HTTP and MQTT endpoints. And to ensure that you're only transferring the data that you need in your cloud applications, we also provide a series of built-in data transformations, as well as support for JSONata, a sophisticated transformation language for JSON data. The NoteHub and Notecard together serve as a device-to-cloud data pump. They're designed to just work and to get out of the way so that you can get your data into your cloud apps and services for processing, visualization, and decision-making. Now that you have an idea about what the Notecard is, let's talk about where it fits with your LoRa-based applications. Now, when it comes to evaluating cellular as a part of your LoRa applications, you have a couple of different options. You can implement a cellular solution alongside your LoRa gateways as a way to reach across distances that might be too far for LoRa, or to replace Wi-Fi or Ethernet for backhaul in the gateway itself and to use cellular as your backhaul option. Now, Wi-Fi or Ethernet are pretty common choices for a gateway if you need cloud connectivity in your LoRa network. You can spread low power end devices kilometers far and wide, ingest everything in the gateway, and then use Wi-Fi or Ethernet to connect to a cloud service like the Things network or your service of choice. But in the IoT, Wi-Fi and Ethernet are often not ideal solutions, and cellular can be a better choice. In the context of a LoRa gateway, cellular means that you can deploy gateways in places where Wi-Fi or Ethernet may not allow, that you can isolate your gateways from your LAN networks, which can be ideal in cases where the location of deployment, like a building or a facility, has unreliable Wi-Fi, or you want to completely isolate your gateway for security reasons from the Wi-Fi available in an area. You can also provision gateways and deploy them in seconds, which wouldn't require on-site AP configuration or anything like that. And then finally, gateways can continue to use Wi-Fi or Ethernet, but use cellular as a failover or backup when Wi-Fi is unavailable. And this can be especially helpful if end nodes are battery powered and the gateway has access to a UPS, so the network can continue to operate even if mains power is unavailable. Now, if you're building your own gateway and you want to use cellular, you have a number of different options for integrating it, right? You can use a custom packet forwarder using something like the basic station protocol and route all of your LoRaWAN traffic to the Notecard. You could also host a network server like the Things Stack or Chirp Stack on your gateway and create an integration to the Notecard on the other side. Or you could sniff LoRa packets for your specific application and send those to the Notecard itself. But regardless of the choice you make, with a Notecard, it's possible to implement cellular alongside of existing solutions like the Things Stack. This would even allow you to deploy a public gateway that's connected to the Things Stack while using the same gateway to capture and forward packets for private end devices to NodeHub or to your own cloud applications, which can be a really powerful way to explore using cellular, to provide cellular's default backhaul, but also to just build solutions that can be public use, but also leverage for your own private deployments. To learn more about the Notecard, visit blues.io. And thanks so much for your time today. I'm happy to answer any questions that you might have in chat. Hopefully you have a great rest of the event, but please do stick around, answer some questions. And if you're interested in trying out the Notecard, click the interest button to the side of the window here, and we'll send you a discount code for 25% off any one of our dev kits. Thanks so much for watching.